So this is just a quick chart showing the history here, 31 years of lithium battery progress. So just to keep everything the same, we're talking about 18650s, which have been a fairly dominant form factor size for that time period, and watt hours per kilogram, the energy density. So from about 1991 to 2005, a 14-year time period, we saw the energy density increase by 2.2 times, which is great improvement. Hooray. We're up then by 2022, we're up to about 270 watt hours per kilogram, but that's a 17-year time period for another 0.74 times increase. So diminishing returns, more and more time to get smaller and smaller amounts of improvement. Now, we're expecting to see this continued trend throughout, moving forward. This is just the last 30 years, but I expect there's evidence that it will keep going. The trend you see in a lot of battery electric vehicles you can buy, where they show, oh, it's 100-mile range, then 200, then 300, then 400, is that if you look into how they're doing that, a big piece of how they're doing it is they just keep throwing heavier and heavier batteries into the car. So, make the battery weigh an extra 300 pounds, make it weigh an extra 500 pounds, take 100 pounds of the vehicle structure and give it to another, to the battery. Things like that. And so that's been a very big piece of how they've been continuing to increase the range of the car, is just a heavier battery. The improvements in the watt hour per kilogram of the chemistry have been small and decreasing. In the lab, there are some promising batteries on the horizon, solid state, high silicon content, lithium air, lithium sulfur, lithium metal, etc. A lot of those have a lot of problems still, and problems in fabrication, problems in production, problems with cycle life, problems with temperature, problems with safety, problems with cost. So there's a lot of problems with those that still have to get worked out. And I am fairly confident that eventually they'll continue to tweak and work those. So we'll continue to see this trend go. But those aren't going to come out and be this miracle thing we have, and then there'll be another miracle, another miracle. We're approaching the physical limits of the rechargeable chemistry battery. And as those ones in the lab today, over the next, 10, 20 years or so, start to come into market or whatever, we'll continue to see improvements here. I'm expecting the ultimate battery eventually, I might not see it in my lifetime, will cap out around, say, 400 or 500 watt hours per kilogram as a maximum before you just hit the physical limits. But we're not going to get there next year or in 5 years. And the trend won't be perfectly smooth like this line shows. It'll be up and down or whatever. But it's going to be continually less improvement, more time, less improvement, more time kind of thing. And that's what we're seeing.